right. Good morning, everybody. Welcome. Thank you so much for joining us today, and I hope this conference has been great so far with lots of good learning. I believe that if you're here, you probably face some database performance challenges. And if that's the case, you came to the right place, because in today's session, we're going to talk about database performance monitoring in Amazon RDS. And really the goal and the outcome of this session is for you to be equipped with the knowledge about the different AWS monitoring tools and offerings. You will learn when and how to use each one of these tools and how they can help you overcome even some of the most complex database performance challenges. My name is Pini Dibask. I'm a database specialist solutions architect, and as part of my role at AWS, I help customers across EMEA, supporting them in the cloud data journey. And later in today's session, I will be joined by Gal Cohen. Gal is a software architect from Autodesk. So you will have the opportunity to hear directly from a customer about their digital transformation journey and how their teams improved application performance, availability, and visibility using the AWS monitoring offerings. Before we get started, I would like you to take a moment and think about what do these three pictures have in common. Okay, so we can see here flashlight, radar, and magnifying glass. All right, you probably all guessed it right. These are three pictures that show three tools. Each one has its own mechanism to improve detection and visibility. And the reason this is a good analogy for today's session is because when it comes to database performance, you can't fix a performance bottleneck that you can't see. Database performance diagnostics and troubleshooting is all about visibility, which is why these three pictures are a good analogy for today's session. So let's get started with the agenda. We're going to start out a bit slowly, setting some context, telling you a little bit about Amazon RDS, and then we will dive deeper into the various monitoring tools and offerings that AWS provides. In the second part, you will see a demonstration, so you can see how we actually diagnose and troubleshoot performance challenge in Amazon RDS. After that, you're going to learn about the latest innovation with performance diagnostics and troubleshooting. Who here heard about DevOps Guru for RDS? Okay, not many, roughly 20%. DevOps Guru for RDS is the latest innovation. It was actually announced as part of last year's reInvent, and it allows you to take performance diagnostics and troubleshooting one step further by becoming even more proactive. So it will give you the bottom line, the recommendations. It will automatically find the performance bottlenecks and will help you understand what to do next. After that, I'm going to hand it over to Gal, and Gal will share the Autodesk success story. And as I mentioned, you will have a good opportunity to hear about a real-world example of how Autodesk managed to resolve database performance challenge even before it made an impact on Autodesk end users. So let's get started. I assume many of you are already familiar with Amazon Relational Database Service or Amazon RDS, but just to level set, Amazon RDS is a fully managed relational database engine. And with Amazon RDS, you can focus on building new apps and optimizing your apps and innovation instead of focusing on the mechanics of database operations and maintenance, such as provisioning, upgrades, backup, disaster recovery, scaling, etc. All of those operational tasks can be fully managed and automated by AWS. So you can really innovate and focus on the business needs. Amazon RDS supports various popular engines. As you can see in this slide, we support Oracle, SQL Server, MySQL, MariaDB, Postgres, and Amazon Aurora. Now, Amazon Aurora is unique because Amazon Aurora is a cloud-native database engine which was designed to provide the enterprise-grade security, availability, and reliability of commercial-grade databases, but at a much lower total cost of ownership. And due to Amazon Aurora unique features and characteristics, it is actually the fastest-growing service in the history of AWS, and tens of thousands of customers use it today and trust it as the relational database engine. All right, so let's start to dive a bit deeper. There are actually 3 levels of monitoring in Amazon RDS: instance level, operating system level, and database engine level. At instance level, you should use Amazon CloudWatch. I'm sure many of you heard about Amazon CloudWatch and use it today. Amazon CloudWatch is AWS's main monitoring and observability solution. So it enables you to monitor your entire application stack and all of your AWS resources. And it also allows you to monitor Amazon RDS. So you can monitor instance-level metrics such as CPU and memory utilization, storage throughput, storage IOPS, and dozens of other instance-level metrics. When it comes to deep dive operating system monitoring, so let's assume you would like to get more visibility into granular OS-level metrics such as Linux huge pages activity and swap activity, all of those granular OS-level metrics can be obtained and can be monitored using Amazon RDS Enhanced Monitoring. So we covered instance level and OS level, but the main focus for today's presentation would be actually the database engine level. So when it comes to deep dive SQL analysis, we offer Amazon RDS Performance Insights. Who here uses Performance Insights today? Okay, roughly 50%. That's good. Amazon RDS Performance Insights is a great tool to use. We're going to cover that deeply in today's session. And also, I mentioned previously some of the latest innovation with Amazon RDS. So now we have DevOps Guru for Amazon RDS. So by using automated performance diagnostics powered by machine learning, you can actually simplify performance diagnostics and be more proactive. So we'll talk about all of those tools in today's presentation. Let's start with the instance level. We mentioned Amazon CloudWatch and how it is a good tool for monitoring instance level metrics. One of the great things about Amazon CloudWatch is the alerting. So you can create alarms. It actually has out-of-the-box integration with Amazon Simple Notification Service, Amazon SNS, which is a fully managed messaging service. Why is that beneficial? Because with Amazon CloudWatch, you can also notify other AWS services and protocols, such as SQS, AWS Lambda, HTTP, HTTPS. So let's assume you would like to alert and provide an email notification or SMS notification to your team members if any metric value has exceeded its threshold. You can do that simply with Amazon CloudWatch. But what if you would like to do some more advanced actions? This is where the integration with other services could be helpful. Imagine a scenario where you need to increase storage throughput because it becomes maybe a bottleneck, and you want to do that automatically upon exceeding a specific threshold of storage IOPS or storage throughput. By integrating with AWS Lambda, for example, you can run very simple commands and do that automatically without any manual intervention. So all of those capabilities of the integration with SNS makes CloudWatch very useful. One of the common questions I get, and I know many of my colleagues get about Amazon CloudWatch, is how do we actually store and retain metrics in Amazon CloudWatch? And I was thinking that the best analogy I can share with you is the pyramid model. So we can see at the top level, we have the most granular resolution. We call it high metric resolution. It could be actually up to 1 second, so very, very granular resolution. However, also for the shortest time period. So less than 1 minute, we store it for 3 hours. And then we have standard resolution, which is 1 minute, that we store for 15 days. And after 15 days, the data is still available, but it is aggregated and is retrievable in a 5-minute resolution that we store for 63 days. And then after 63 days, the data is further aggregated and is retrievable in a resolution of 1 hour for up to 15 months. Now, why do we do this pyramid model when it comes to retention and resolution? The reason behind that is because when you think about it, as data ages, it becomes less and less important to get the high granularity and resolution. So for example, if you look at the last hour, it makes sense that you want to see very granular data points. But does it make sense to look at 1 second data points when you look at time period of a couple of weeks or a couple of months? It will be too many data points, too much noise, not very effective, not very efficient. And this is why we have this pyramid model. This is out of the box Amazon CloudWatch pyramid model for retention and resolution. It's not something that is configurable, but I wanted you to be aware of that because this is one of the common questions I get from customers about Amazon CloudWatch. Amazon CloudWatch also has a very intuitive alarm wizard. So you can easily define things like threshold for the metric. You can also define the evaluation period for alarm. What statistic to use to calculate the metric value over that period? It could be, for example, mean, max, average, sum, count, etc. Alarm threshold doesn't have to be static. It could also be dynamic. So probably when you think about alarm threshold, you're thinking about maybe we should say 80% CPU utilization or X IO per second. So sure, you can do that. You can define static thresholds. But what if you would like to be even more proactive and use some of the latest innovations? So you can use anomaly detection. And by using machine learning, we analyze past metric behavior, and based on historical patterns of hourly, daily, and weekly behaviors of each metric, we can build a model of expected values for each metric. So we know what is the expected metric behavior at any point in time. Now, why is that important? It is so common nowadays to see customers that have hundreds of databases, and each database may have hundreds of metrics that they want to monitor. It's not very easy to start and configure manual thresholds, static thresholds for each one of those metrics. By using anomaly detection, you let AWS calculate metric behavior, expected behavior over time based on previous analyses. Now, this is an example, what you can see right now, of the band, which represents the expected range of read IO per second in Amazon RDS for Oracle, for example. So as I mentioned, this is a great way for you to simplify performance diagnostics and create alarms that are based on anomaly detection. What you can configure, even though in anomaly detection you don't configure a static value, you can configure the sensitivity. In other words, you can set this range, this band of possible values to be more or less narrow. So essentially, you can change the likelihood of an alarm being triggered. While Amazon CloudWatch is great for instance-level monitoring, we just saw some of the capabilities Amazon CloudWatch provides. Sometimes customers require the additional visibility into more granular operating system metrics. So I mentioned things like swap activity, Linux huge pages. And also, one of the common requests by customers is they would like to understand the memory and CPU consumption associated to each thread and process at the OS level. For those use cases, Amazon RDS Enhanced Monitoring is a great tool to use. It is part of Amazon RDS, so you just need to enable it. It's a fully managed tool. It's not something you need to install or deploy or anything like that. Behind the scenes, we actually deploy a local agent to make sure we provide the depth of OS level monitoring. So this is what we do behind the scenes. Just note that the retention period for Amazon RDS Enhanced Monitoring is not the same as CloudWatch. It is by default 30 days, but it is configurable. So you can change it to 1 day up to unlimited retention. Obviously, as you retain more data, that can have cost implications, but you have the flexibility to change the retention in Amazon RDS Enhanced Monitoring. All right, so we covered both instance-level monitoring with CloudWatch and granular operating system monitoring with RDS Enhanced Monitoring. Let's talk about deep dive database engine level, and this is going to be the main focus area for the presentation. Performance Insights is a tool that allows you to measure database load over time and monitor and troubleshoot database performance. It also has the ability to do SQL analysis, so you can analyze the behavior of different SQLs running in the database. This is not something you can do with CloudWatch and RDS Enhanced Monitoring. One of the great things about Performance Insights, many of our customers who are working with RDS are not necessarily database experts. Many of them are developers, DevOps engineers, and they don't have deep database expertise. And yet, they find this tool very useful to diagnose and troubleshoot database performance. It is also available for all of the Amazon RDS engines, and it is integrated and fully managed. In other words, very similar to RDS Enhanced Monitoring. You don't need to deal with installations, upgrades, anything like that. This is a fully managed tool that comes as part of RDS. You just need to enable it. So I mentioned that in Amazon RDS Performance Insights, we measure database load over time. But what do we mean by that? What do we mean by database load? So we're measuring the average active sessions. An active session is a session in the database that is running a query and is waiting for a response back from the database. It could be due to many reasons. Storage I/O, latency maybe, commit acknowledgement from the storage subsystem, maybe database blocks, a couple of different sessions that try to access the same resources, the same records at the same time. All of those things can cause wait events. So in other words, when we collect data in Performance Insights, every second we sample all of the active sessions. In other words, all the sessions that waiting for SQL to be executed. And we collect all the associated performance statistics and dimensions. So for example, the SQL that the session is running, dimensions could be things like the application server that is running the SQL, the database name, the database user, the program. So you get very deep visibility into all of those different dimensions. But one of the key dimensions, which we will talk about, is wait events. Wait event is essentially an indication of why the database is waiting. So when you run a SQL, behind the scenes, there is a couple of lines of codes, right? Everything is code. And in those lines of codes, something is waiting. It could be, as I mentioned, due to many different reasons. So we collect all of those wait events as well. And that can give you an indication of why the database is waiting. Put simply, wait event is one of the most important dimensions because it can let you understand why the database is having some performance bottlenecks. OK, so let's continue with the performance insights. I mentioned that we sample the data every second. And as we sample the data every second, some engineers might be concerned about missing data in between. But what we have found is that collecting database activity every second actually describes database activity very well. And one analogy is in films. When you go to the cinema, you watch a movie, you actually get to see X frames per second. But as a viewer, from your perspective, you get a very coherent and very clear and complete picture. So this is a great analogy of performance insights. We sample every second, but it still describes database activity very well. All right, so when it comes to database performance, I always encourage my customers to think about the database as this big ocean of SQLs. And each SQL is a fish in the ocean, right? We want to detect and focus on the big fish in the ocean. So usually those queries that are long-running, or even short-running queries that are being very highly repeatedly queried. So you can see here 3 different users. Each one executes query in different times. You can see that there are some slow queries, some queries that run very often. These are the types of queries that are very likely to be sampled by Performance Insights because, again, we sample every second. Some queries might be very short-running and run very rarely, so maybe sub-second latency, and they run once a week. We might miss them, which is completely fine. Because remember, Performance Insights is not an auditing tool. Performance Insights is a database monitoring and diagnostics tool. If we miss some queries that are less than 1 second, that run maybe once a week, that's completely fine. This is probably not going to be the query that causes performance bottleneck in your databases. So this is why it also reminds me of the analogy that I just mentioned. When you think about the film, right, you might miss frames per second, but from your perspective, you see a very coherent and clear picture. Capturing database load from multiple sessions, that's what we actually do in Performance Insights. So you can see we have here 4 different sessions, 4 different users running SQL in different times. And essentially, we're stacking concurrent load. So this is the graph that shows the stacking of all of those different SQLs that are running during the sampling of Performance Insights. And this graph shows you, the graph at the bottom, shows you very clearly when the database was having a high level of concurrency, when the database was having a low level of concurrency, or even when it was idle. So with this graph, you know exactly at what point in time the database was having some bottlenecks. However, this graph doesn't tell you why. And this is why the wait event breakdown is so important. Because as I mentioned previously, this is a key dimension. In every query execution, throughout every query execution, we collect all of the associated wait events. And we also assign different colors to different wait events. The benefit of assigning different colors to different wait events is because it can allow us to tell you a very clear story about database performance over time. So we can provide you a clear, informative graph. And this is how it looks in Performance Insights console. So now you can see a screenshot taken from Performance Insights. And you can see this horizontal line, which represents 2 vCPUs. So this RDS instance actually has 2 CPUs. And you can see we have 2 spikes. One spike is the green color, which represents CPU load. The other spike is the red color, which represents database blocks. So possibly 2 sessions trying to update the same records at the same time that could cause some database blocks. Average active sessions is a key dimension, is a key metric in Performance Insights. And I would like to share with you some guidelines or some ways to interpret average active sessions. So when average active sessions is 0, it essentially means that the database is idle. It's not serving any application workload. If someone comes to you and asks you, I believe the database is having some performance challenges, and then you look at Performance Insights, and you see that database average active session is 0, probably means that the database is not the bottleneck. So this is just a good indication, a good guideline to have. Also, when the average active sessions is below 1, it means that there are no major blocks. Because if there was a session waiting for a couple of seconds or a couple of minutes due to a blocking lock, you would expect to see a spike of at least 1 average active session. When the average active sessions is below the number of vCPUs in the instance, it means that there is CPU available in that machine. So if, for example, you would look at CloudWatch and you will check the CPU utilization, you will see it is below 100%. There are CPU resources available. When average active sessions is above number of vCPUs, this means that there could be possible bottleneck. As you can see in this graph, in this picture in the right section, at 2:20 p.m. roughly, there was a spike. You can see the green color. And that represents a possible bottleneck. In that case, the action item would be either rightsizing or SQL optimization. But this is not a healthy database workload. If you look at Performance Insights and you see this big spike, which is above the number of vCPUs in the machine, then that could be problematic and require some actions. One of the benefits of the cloud is elasticity. And many customers also use Performance Insights for right-sizing. As you probably know, those of you who work with Amazon RDS, there are so many different types of instances in Amazon RDS, and instance shapes, instance types. It's really hard sometimes to make the right data-driven decision about what is the best RDS instance type to use. So many customers leverage Performance Insights for that. And in this case, we can see CPU load, which is constantly, significantly below the number of vCPUs in the machine. This means that this is a probably oversized instance. This is a good indication that we have cost optimization opportunities here because maybe we can downscale the instance and pay less money, right? Every company would love to save money on their AWS resources. On the other hand, if we see that the CPU load is constantly significantly higher than the number of vCPUs in the machine, here we can see 2 vCPUs, but the average active session gets to almost 10 average active sessions, so significantly higher than the number of vCPUs in the machine, then this is probably an undersized instance. This is an instance that needs to be scaled up, or alternatively, you should take actions such as SQL optimization to make sure that the average active sessions goes below the number of vCPUs in the machine. One of the things I mentioned previously is the fact that we collect a lot of dimensions. So, for example, the application server that is running the query, the database name, the database user, the program, etc. So in this slide, I would like to highlight the dimensions. You can see those dimensions, and it allows you to drill down, slice and dice the activity by different dimensions, which is very powerful. Imagine a scenario that you would like to filter the database workload by user David, who executed the query on database cells in a specific time period. All of those deep dive diagnostics you can do with the multi-dimensional analysis. So take advantage of the fact that you have so many different dimensions. You can see here, it's actually a screenshot from the documentation, so we can see which dimensions are supported to which database engines. And as you can see, we have a lot of dimensions supported across all of the RDS engines. Also, we will continue to improve feature parity. As you can see, there is no 100% parity across engines, but we will continue to improve feature parity where it makes sense to do so based on our customers and market demand. As you probably know, AWS is a very data-driven and customer-driven company. So if you have any feedback about a specific dimension, for example, that you would like to see added in Amazon RDS for a specific engine, feel free to talk with your account team or even to talk with me after this session. We will be outside of the room. Happy to get feedback and address any questions that you may have. All right. So we talked about CloudWatch, RDS Enhanced Monitoring, and Performance Insights. And now I would like to show you a very quick demo of a very simple performance diagnostics with Amazon RDS. So the demo is going to be simple. I pre-created a table with 1 million employees. And what you can see here is that in the first execution, I'm going to randomly select employees by their name. And I'm going to update the salary, going to increase 10%, right? Everybody will be happy for 10% increase, right? Woohoo! All right. In the second execution, we're going to do something very similar. But in the second execution, we're going to search for the employees by their ID. Very simple difference, right? First execution, we will search by a name column which is not indexed. It will create a lot of full table scans. Second execution will be based on an index search, so it will be much more efficient. And then I would like to observe and look at the differences in performance insights. So this is what we will do. Very simple. I just want you to see how the data and how the workload is being reflected in performance insights. All right, so now you can see the RDS console. We have Aurora Postgres cluster, one instance, so pretty simple. We go to the monitoring tab, and we can see the CPU utilization is very low, right? Less than 10%, so this instance is not working very hard. Now we go to Performance Insights, and we can see the average active sessions is 0. If you remember what I mentioned a couple of slides ago, 0 average active sessions means database is idle. It's not really serving any database, any application, not doing any work. So this is a good indication of what we've saw previously about the CPU utilization that is very low. You can also see other metrics like here in Performance Insights, 7.9% CPU utilization, very low. So this is aligned with what we've seen in CloudWatch, which we had less than 10% CPU utilization. Now I use pgbench. pgbench is a Postgres benchmarking tool. I actually ran this benchmark from 5 different clients for 3 minutes. Don't worry, we don't need to wait for 3 minutes. I pre-recorded that in advance. But I'm running from 5 different clients those random searches of employees by their names. And look at the spike of CPU load, which is significantly higher than the number of vCPUs in the machine. We can also see the SQL and the function that is actually waiting. And we can see other associated metrics at the top. There are actually dozens of counter metrics that you can add. But you can see we reached to 99.97, essentially 100% CPU utilization. Commits per second is 7. So the transactional throughput is also pretty low, 7 transactions per second. And now I'm going to run the exact same benchmark, but this time I'm going to search by the ID of the employee. This is a primary key. This is an index column. Obviously, it will look different. And now we can see how it's being reflected in Performance Insights. First of all, average active sessions or database load is significantly lower than what we've seen previously. We can also see this different color, the orange color, which represents a different wait event, IO exact sync. And we can zoom in to a more specific time period so we can see the data in a higher granularity. And when we look at the metric at the top, we can see CPU utilization is 90%, so 89 point. And we can see that 817 transactions per second. So the transactional throughput is significantly better than the previous execution. Previous execution was 7.1. So obviously, it behaves much better. And we can also filter by different dimensions. So we can see database MyLab. We can see that the application is pgbench because we executed the benchmark from pgbench. We can filter by SQL. There are lots of different dimensions. And I highly encourage you to use the dimensions because it enables you to get more visibility about what is happening behind the scenes. So pretty simple benchmark, 2 executions, one uses the index, one uses full table scans. And you can see that in the second execution, we have this orange color that represents the new wait events. Let's talk about that. And let's talk about what we've learned. We had 2 runs. The first one reached to 100% CPU utilization. Transactional throughput was very low. We're talking about 7 transactions per second. Second run, 90% CPU utilization, 800 plus transactions per second, so much better transactional throughput. However, we noticed a new wait event, the orange color. This is actually a commit acknowledgement latency from the storage subsystem. Now, why do we have that? Because the throughput has increased so dramatically that the database needs to handle a much higher commit frequency. The good news is that because we have performance insights, we have the visibility about what is the bottleneck. So what we can do, we can take further actions. For example, we can group and batch updates together. Instead of running a transaction, opening a transaction per each update statement, we can do that for maybe 100 or 200 update statements. And this way, we don't need to open too many transactions, and that could be much more healthy from a database performance standpoint. But imagine how hard it would be to get to that visibility and to that conclusion without having a tool like Performance Insights. All right, so for a long time, you've been telling us that you like a lot of things about Performance Insights and Amazon CloudWatch and RDS Enhanced Monitoring. It lets you explore all kinds of issues, all kinds of performance problems. But you've also told us loud and clear that you need more help with tracking down potential performance issues. And even more importantly, figuring out what to do about those issues. So we'll listen to your feedback. As I mentioned previously, we at AWS are very driven by our customers' feedback. And in last year's reInvent, we announced DevOps Guru for RDS. And DevOps Guru for RDS goes one step further by using automated diagnostics powered by machine learning to let you understand what is the bottleneck and what action items can be taken to remediate or resolve database performance challenges. So I would like to show you a quick example. Imagine having an e-commerce website serving many customers around the globe. And there is a specific product that now received a big exposure in a major television channel, and orders going through the roof. Many people order the same product at the same time. Behind the scenes, every order initiates a SQL statement that updates the inventory table and reduces the amount of available items by 1. Now, because so many different orders that run concurrently, this SQL will be executed concurrently. It will cause database blocks. A lot of update statements for the same records at the same time. Now, let's assume you look at the CloudWatch and you look at performance or Performance Insights and you look at the CPU utilization. And you see nothing too dramatic, right? Less than 15% CPU utilization. You will probably not even get an alarm in CloudWatch because it's so low. DevOps Guru for RDS understands that it's not enough to look only at the CPU. It looks at the bigger picture. And by looking at the bigger picture and understanding what is the trend of the workload, what is the typical workload trend, and looking at the average active sessions and looking at the wait events, it can identify the root cause of the performance bottleneck. So in this case, it found that 951 times more database load or more average active sessions compared to a similar typical time period. Obviously, something is wrong here. 951 times more. It also found, as you can see at the bottom of this screenshot, it found that we have 137 times more database connections, which is also a big problem because this is not a typical behavior for this database. Not only does DevOps Guru understand and identifies that there are some anomalies, but it also lets you know what to do next. What are the next steps that you can take? So in this case, Amazon DevOps Guru for RDS identified the root cause of the database bottleneck is locks. As you can see, it tells us that 99% of the total database time or total average active sessions is associated to database locks. It also shows us which SQL is waiting, and it gives us some recommendation. For example, as you probably all know, when there is a high frequency of database connections being opened and closed in the database, that can exhaust memory and CPU resources. So for example, in this case, it recommends on considering connection pooling. These are the types of things that DevOps Guru does for you. So it allows you to be more proactive, it simplifies database performance, and gives you the bottom line. So you don't need to work too much hard on performance insights and try to identify the issue yourself. Now, this is just one example. There are actually many other scenarios that DevOps Guru supports. And we will continue to invest in this area because from our perspective, it is very important for us that our customers will have a very easy experience when it comes to database performance, troubleshooting, and diagnostics. So we would like to make this experience as simple and intuitive as possible. So definitely, we expect to continue work on this area. Now, we covered CloudWatch, RDS Enhanced Monitoring, Performance Insights, and DevOps Guru for RDS. So we covered the 4 tools that I mentioned in the beginning of the presentation. But I would like to show you how customers can actually use some of these tools in real-world database performance challenges. So I'm going to hand it over now to Gal. And Gal, stage is yours.
Thank you, Penny. It's a pleasure to be here this morning. In the next 15 minutes, I'm going to demonstrate how I personally use Performance Insights, how Performance Insights help me to resolve a customer-facing incident. I'm Gal. I'm a software architect. And just like you, most of my daily work is around databases and infrastructure. So who knows Autodesk? OK, that's amazing. So Autodesk is a global leader in 3D design, engineering, and construction software. We believe a better world can be designed and made for all. This is why we believe we should empower our customers with tools to achieve better outcomes to their businesses, projects, and products. Tools like Autodesk Maya, AutoCAD, Autodesk Fusion, and Autodesk Construction Cloud, which we're going to talk about just soon. You probably already know that we deal with construction projects, but we also deal with media and manufacturing. Just for instance, you probably know Avatar, Avatar the movie. We helped Avatar to win the Academy Awards for special effects. We help our customers to create new paths towards efficiency, sustainability, and growth. Greener cars, smarter factories, and greener buildings. So now let's talk about Autodesk Construction Cloud. Autodesk Construction Cloud is a platform, cloud-based platform, which in a sense is similar to Google G Suite with Google Docs, Google Drive, or Microsoft Office 365 to help construction workflows, from the design phase to plan, build, and operate. It is a set of more than 20 applications based on AWS services. We use ECS for our compute, SQS and SNS for queuing and messaging, Elasticsearch for caching, S3, and of course, RDS. We do use other AWS services, but these are the most commonly used ones. All the above applications databases are being replicated to our data lake. We use DMS for real-time replication. We replicate it to a single Aurora cluster where we produce matrix, reports, and data extracts to our customers. From the other end, our analytics teams are using Athena on top of S3 in order to produce cross-customers matrix. So these days, our development teams own the databases and infrastructure components, but it wasn't always like that. Since 2010, multiple startups were acquired by Autodesk, some of which were already onboarded to AWS, and the rest of them used different web hosting services. By 2015, the different startups were onboarded to AWS, and by 2018, different DevOps teams owned the different infrastructure components, and DBA teams owned the databases. By 2021, our development teams gained ownership both on databases and infrastructure, which raised multiple knowledge gaps. This is where Performance Insights excels. So this was the setup to our story, and this is the juicy part. So a few months back, I started to get alerts about one of our applications' RDS instances, Postgres instance. It was about huge storage drop, which didn't correlate to usage. So I opened RDS console, and I saw exactly what I said. And I knew at this point of time that it's going to be a hell of a night. The potential business impact of such an incident, of course, is service degradation, meaning we're going to breach our SLAs with our customers. API outage, meaning our third-party applications that are consuming our APIs will suffer from outages as well. And offline job failures, meaning emails, notifications, and batch processing jobs would fail. The issue was confirmed with additional data points. The graph that you see here is our health endpoint graph. It represents the latency our database currently responses to our health API. And in addition to that, we saw the system note about our burst GP2 balance, the IOPS. At this point of time, we didn't know what the problem is, and we didn't have a clue. So we opened Performance Insights, and we noticed straight away, here in pink color, the buff file write parameter. At this point of time, we didn't know what's the root cause of the problem, but we had the buff file write parameter, and we continued the investigation. We opened AWS documentation and searched for it. This is the point, let's say this is the turning point. It pointed us to the workman parameter, the Postgres parameter. We didn't know either anything about it, so we continued the research. So apparently, it is the parameter that sets the threshold for a query execution to use the disk. Its default value is 4 megabytes, meaning if a query execution requires 3 megabytes, it will use memory only. If it requires 5, it will use both memory and disk. It is a dynamic parameter, meaning an instance reboot is not required, which is awesome. And we decided to set it to 50 megabytes. We continued to monitor the environment after setting it to 50 megabytes because we were afraid doing so. It is worth mentioning that we can set the workman parameter in the user level, session level, or DB level, but we decided to do it via RDS console in the group parameter group page, just to spare the time deploying the code changes. So at the minute we set it to 50 megabytes, we saw that the storage drop stopped. And as I mentioned earlier, we continue to monitor the rest of the environment and all the different CloudWatch metrics. We saw in the right-hand side graph that the write IOPS decreased rapidly. And over the left-hand side, you can see that the storage was freed. So this was our use case. And now let's talk about the alternatives that we had during the incident. The first alternative was to increase storage, which eventually will result with more IOPS, but it won't resolve the issue. The second option was moving to provisioned IOPS, meaning pay-as-you-go model. Once again, this won't have resolved the issue. And the third option was optimizing our SQLs, which eventually we did, but after 2 weeks, not during the incident itself. So this was, let's say, our alternatives, and eventually the choice that we made with changing the parameter group workman value was the shortest way to resolve the incident. Now let's move on to our conclusions. So our first key takeaway is once we hand over infrastructure and database ownership from DBA teams or DevOps teams to the development teams, we need to provide them with tools to mitigate different knowledge gaps that were created. Our second key takeaway is once we adopt the you build it, you own it approach, a better sense of ownership is developed in the development team, which eventually leads to less incidents. And the third key takeaway is about the business impact. Now, since the development teams doesn't have external dependencies in terms of creating new resources or launching whatever AWS services out there, since they own the infrastructure and databases, features are being shipped faster. And on a personal note, since we started to use Performance Insights, I sleep better at night. Thank you.
All right. Thank you very much, Gal, for sharing the Autodesk story. This is a great example of how a customer, a big customer, managed to resolve a database performance bottleneck. And in the case of Autodesk, as Gal just outlined, even before it made an impact on their end users. So thank you so much for sharing this story, Gal. I will just summarize by saying what I mentioned in the beginning. Database performance diagnostics and troubleshooting is all about visibility. You can't fix a performance bottleneck that you can't see. And our goal today was to show you how using the AWS monitoring portfolio, you can diagnose and resolve even some of the most complex database performance challenges. Use the right tool for the right job. We talked about different use cases and different levels of monitorings, instance level, operating system level, and database engine level. So definitely take advantage of the solutions that we offer in each one of those monitoring levels, and always aim to be proactive rather than reactive. Use the latest innovation that we offer, such as DevOps Guru for RDS. We talked about anomaly detection, threshold, dynamic threshold with Amazon CloudWatch. All of those tools and features can make your life much easier. And as Gal said, we all want to sleep good at night. So we will stick around for a couple of more minutes for questions. We will be outside of the room just to respect the next speaker. So we will be outside, and if you will have any questions or anything that you would like to talk with us, we would love to chat with you. Just one last note, as you probably all know, AWS is a data-driven company, and we would love to get your feedback. So if you can spend a minute and provide the feedback in the survey, in the mobile app, we would greatly appreciate that. Thank you all, and enjoy the rest of the conference.